Hello everyone, Mr. Minix. My name, math is my game today. It's a quick lesson on logarithms. I'm going to start off by saying a log is an exponent. If you don't know what a logarithm is, it's an exponent. I'm going to go on to say a log is the power, the power to which the base is raised to equal, I'm running out of colors here, I'll go with the toothpaste color, the number whose log is being taken. So the final exam, about half of it, requires that you understand what a logarithm is, how to evaluate logs, how to expand logs, how to write things as single logs, and how to solve log equations. So those first two definitions probably don't make any sense, but this third one will make sense of the madness. There's one form called exponential form, and we've seen it time and time again. And there's another form called log or logarithmic form. And the definition of a log actually has both of these forms in it. It's kind of unusual. Well, it's not kind of unusual. It's just some phenomenon that you need to be familiar with. All right. So with logarithms, there's certain skills that you need. And I'm not talking about the rainbow of fruit flavors, but there's certain skills that you need. So here's the definition of a logarithm. And I should probably actually switch these things around. I should have the logarithmic form over here and exponential form over here. So what mathematicians say is they write the word log. They'll say the log with a subscript of b. Now that's the base, in case you can't tell what I got going on here. The number whose log is being taken is y. Okay, I haven't put it in parentheses. Maybe I should. And that equals, a log is the power. So it's equal to the power, the exponent. So what I've got going on right here, this is logarithmic form of some expression. And the equivalent exponential form of an expression is something we've seen all along the last couple weeks. Y equals the base. In this case, the base is the b to some power. And remember, log is a power. That x is our power. And so being able to go from one form to the next is a skill that is detrimental to understanding logarithms. Okay. Anybody have any questions so far? Anybody want to give a shout out yet? My second period and first period class had these notes live. This is just going on to YouTube. The future Mr. Minnick. Anybody else? How about Kirk Hammett? Anybody know who Kirk Hammett is? Well, I'm trying to write with my smartboard and it's not letting me write for some odd reason. So here we go. Example 1. Write each expression in log form. So if you did the Math Excel homework, you know that you got to do this. And some of you, I think, figured this out. Maybe we have something like a smartboard that really doesn't want to cooperate a bit. Or maybe we have something like this. Maybe we've got 15 equals 1 divided by 225 raised to the negative 1/2 power. Maybe we have something like 1,000 is equal to 10 cubed. Maybe we have something like 7.38 is approximately e squared. And maybe we have something like 8 is equal to 4 to the 3 halves. So the object of the game here is to put this into log form. So in log form, what you need to realize is you're going to write the word log. You're going to fill in this subscript area with the base. And in this case, it's not 15. And then we're taking the log of some number, and that's going to equal some thing. So we got 3 blanks to fill in. Now, one thing to keep in mind is notice what the base is. In exponential form, the base is the b, right? It's the thing that's being raised to a power. You with me? So in this particular case, our base is what? 1 over 225. Good. Now, the of, forget the of. Remember what a log is. A log is a power, right? A log equals the power. So all that is going to equal the exponent. So everything's going to equal what? Negative 1 over 2. So what are we taking the log of? We're taking the log of 15. Okay. So the interesting thing about a log, and my smart board's probably not going to cooperate with me, this magic marker, but the base to, that's not going to cooperate. Anyway, the base, why is that not cooperating? Anyway, the base to that power, to the power whatever the log is, equals that number, okay? And I know we just kind of went right back to where we started, but anyway, logarithms, being able to switch from one form to the next, real big idea, huge idea. Number D, let's see if we can figure out number D then. What's that going to look like? Anybody? Log base what? Base 4 of 8 equals 3 halves. Good, perfect, nice. We doing all right? Now, I have a feeling that number B, you might have the right idea, but you're going to write it wrong. You're going to do too much work. Number B is a very special type of log. It is called the common log. So what's our base in this? 10. So you might be inclined to say, well, it's the log base 10 of what? Of 1,000 equals 3. Well, that's not wrong, but you're doing too much work. Whenever the base is 10, you don't have to write it. In other words, if the base isn't given and you're using the word log, the base is 10. And if you understand scientific notation, those are quite simple. Number C is kind of the same idea, a little bit different, but same idea. Anybody watch NBC at 5 o'clock? You know what comes on channel NBC at 5 o'clock? Ellen? So number C, you might be inclined to write the log base E of what? Of 7.38 is approximately equal to 2. Well, you don't need to write that. You don't need to write that. Instead, you're going to use the ln. So we would say the ln, or natural log of 7.38, is approximately 2. I don't understand who named it, why they named it that way, but whenever the base is e, we use something called the natural log. And it's weird because whenever you read an expression like this in math, it's read as the log of, even though it's the natural log. For short, we just say the log of. It's kind of like in bowling. You know how people have their own language they use in bowling? Like when you have to get a split and you hit the one pin and the ball deflects off the other pin to the other pin and you get a split. That's called parking the car. Anyway, how are we doing so far, okay? All right, we got 2 more examples to do. Example 2. Write in exponential form number A, number B, number C, number D. The ln of 0.4 is approximately -1 The log base 2 of a half is -1. Is it always going to equal -1? No. The log base 32 of 1/2 is -1/5. Is it always going to be something negative? No. The log of 0.00001 is -4. Okay. Oh, -5. Sorry, that's a neck. That's a neck. So remember here we want exponential form. We want some number equals some base raised to some power. If you understand what a log is, remember a log equals the power. So number A, what's everything? Well, what's our exponent going to be? Our exponent's going to be -1. The base is the subscript. In this case, the subscript is E, and the number we're taking the log of is what's equal to that stuff. So 0.4 is approximately e to the -1st. Who thinks they got number B figured out then? Yeah, what do we got? One half equals 2 to the -1st. Good. And then C is going to be what? Yeah, 1/2 equals 32 to the -1/5. Got the hang of these? And then so the last one, number D, would be what? Yeah, equals 10 to the -5th. And remember, if the base isn't written, then the base can safely be assumed to be 10. Got him? One last example, and that's it. Told you, pretty easy lesson. Last example. Evaluate. If you don't know what that means, it means get an answer that's just one number. So the log base 5 of 1/32. No, that's wrong. That's a neck. Log base 5 of 1/125. That'd be a good one. The log base 16 of 8. The log base 27 of 1. These are all good ones. I'm going to do one more, number D. This is a confusing one. The natural log of E squared. Okay. So what do we think about number A? Any ideas? What you're asking yourself here, is what power do I raise 5 to get the number whose log is being taken? It's going to be negative something. If you cube 5, you get 125, but then you got to flip it. So what power do you raise? It's going to be negative. Who said -3? Nice. -3. -3. So to be clear, this is the question you're asking, but when you answer this, make sure that your answer is real clear. Remember what a log is. A log's an exponent, right? It's the power. The power of what? The power you raise the base to. The power you raise the base to get the number whose log is being taken. What power do you raise 5 to get that? So the answer there is -3. Let's look at number B. What about that? What power do you raise 16 to get 8? What power do you raise 16 to get 8? And you're thinking to yourself, I can't do that without a calculator. 16 to the first is 16. 16 to the 1/2 would be the square root of 16, which would be 4. Maybe we should take these things down to same bases. Could we rewrite 16 and 8 with the same nice base? Remember that one day I was talking about my YSU professor with the Fu Manchu goatee? And he said, everything is a power of 2. Okay, fine. So what's 16 really? 2 to the what? 2 to the 4th. So I want to know what power do I raise 2 to the 4th to get, what power, 8. 8 is really 2 to what power? To the 3rd. So what I've got is 2 to the 4x equals 2 cubed. If the bases are alike, the powers can be set equal. Well, 2 and 2 are the same, so I could set 4x equal to 3. So the answer here is 3/4. I do expect you to be able to do one of those without a calculator. That's the expectation if you take a college algebra class. Number C, let's think about that one. What power do you raise 27 to get 1? What power do you raise almost any? It's 0, good. Yeah, number C. Number C, the answer is 0. And finally, number D, you're either going to love the E stuff and the ln stuff or you're going to hate it. What power do you raise e to get e squared? Not to the e power. What power do you raise e to get e squared? To the second power. To the second power. Now, my first period class, we didn't answer this question. My second period class, we took 15 minutes answering this question. Do you want to know the question? Why logs? Why logs? Why do we need them? Suppose we had to solve this. 5 to the x equals 10. Could you? 5 to the first is 10, or 5 to the first is 5. 5 squared is 25. So our answer is somewhere between 1 and 2, right? Okay. So you're pretty good with the calculator. You could punch in some stuff. You could say 5. Oh, you wanted to end solve? End solve? Well, let's see. Let's see what 5 squared is 25. Oh, my stupid computer calculator's running real slow today. 5 to the 1.5 is 11. So my answer is a little smaller than 1.5. 1.4. Well, it's between 1.4 and 1.5. 1.42. Okay. Well, how about 1.4? Well, it's got to be bigger than 1.4, but smaller than 1.45. Oh, man. 1.431. 1.4305. Oh, man. Do you see how long it's going to take us to find the answer? This is why logs. This is why logs. Let's use some Skittles. Can we write that in log form? The log base what? Base what? Base 5 of something equals something. Now a log is equal to a power, right? So that's going to equal x, so it's a log base 5 of 10, right? So if we took the log, Bueller, my calculator says no. If we took the log base 5 of 10, we would get our answer. And it's going to be 1.4 something, we know, right? So 5 to the 1.43, 1.4306, 7655807. Really? Should equal 10. Oh, 5 to the answer. Oh, so that's an exact answer, and that's why we need logs. Yeah, 5 to the answer power. I said 5 to the answer power. So that's why logs. That's why logs. It's been real. It's been fun. Any other shout outs? Shout out to Trey. Shout out to Matt's mom. I guess that's it. Have a nice day.